So now let's take a look at all of the equations that we have covered so far. For the case of internal flow, we don't have many different geometries. In most cases, 99% of the time you'll be dealing with a flow inside a pipe. So that means the main issue that we need to consider is if the flow is laminar or turbulent. In addition, we need to consider if the flow is in the entry region or in the fully developed region. So these are the main concerns that we have for the internal flow. So first, we talk about the friction factor, which is for the laminar flow, for the fully developed laminar flow, 64 over Reynolds number. So if you have a laminar flow, uniform heat flux, the Nusselt number is constant. So that means average Nusselt number is also constant. And if you have a uniform surface temperature, the Nusselt number is this. So if you have the thermal entry or a combined entry, so you calculate the Garrett's number. From the Garrett's number, you calculate the average Nusselt number for the laminar flow. And if you have combined entry and the Prandtl number is greater than 0.1, then we can use this equation. These two equations can be alternatively used, so you just need to check the range. And the properties here are evaluated. So for fanning friction factor, you evaluate the properties at T film, Ts plus T mean over 2. So for the laminar flow, for the blue equations, you evaluate the properties at T mean, and the green ones means you evaluate the properties at inlet plus outlet over 2. Okay? So if you have a turbulent fully developed flow, so we have Moody diagrams or this empirical equation. So you can also use alternative empirical equation if you have a smooth wall. So this is another equation, but the easiest way to go with is basically the Moody diagrams. And if you have turbulent fully developed flow, the local Nusselt number in a cylinder is given by this empirical equation. The properties needs to be evaluated T mean, wherever that is, T mean here. So you are evaluating this at locally at particular point. So this is the temperature that you need to evaluate as T mean. And if you have a smooth pipe, you use these two equations. If you have a rough pipe, you use the equation for number 3. So we have 3 options for the turbulent flow, fully developed turbulent flow inside the pipe. Okay, so these are the main equations. And again, conceptually this is very similar to chapter 7. The most important thing that you need to do is identify the equation and then decide carefully what temperature you need to evaluate these properties.